All right, so we're going to do some OST review on angle relationships and our parallel lines. So we're going to jump straight into number one of this we do. It looks like we've got a transversal that is cutting through two parallel lines. And two of our angles are marked with some expressions. We're being asked to find the value of x. When we take a look at these two angles, we notice that their relationship is consecutive interior angles, or same side interior angles, because they are inside our parallel lines on the same side of our transversal. So consecutive slash same side interior angles. Both names mean the same thing. And we know that same side or consecutive interior angles, they are supplementary, which means that they will add up and equal 180. So I'm going to write down that note. Supplementary means that they equal 180 degrees. So that means that we are going to take our two expressions, add them together, and set it equal to 180. So we have 3x plus 45 plus 3x minus 15 equals 180. We're going to draw a line down our equal sign. We're going to solve for x here. So the first thing that we notice is we actually have some like terms that we need to combine. We have 3x plus 3x. Both are x's, so they add together and give us 6x. And then we have a plus 45 and a minus 15. So 45 minus 15 is 30. So that's going to be positive 30 plus 30. And 180 drops down on the right side. Now to get x by itself, the first thing we got to do is subtract the constant, subtract 30 from both sides. I'm going to scroll down just a touch here. So when we subtract 30 on both sides, 6x will drop down on the left. 180 minus 30 is 150. And then lastly, divide both sides by the coefficient, which is 6. That's going to give us x on the left, and then 150 divided by 6 is 25. So what is the value of x? X is 25. All right, so moving right along to number 2, we've got a transversal crosses a pair of parallel lines as shown. This time, we're not looking for x, we're looking for the measure in degrees of angle theta. So we're looking for theta, which is this guy right here on the left side of our transversal and parallel lines. So to find out theta, I need to make a connection with another angle here. And I'm looking at this 5 parentheses 2x minus 1. And I know that those two angles are corresponding angles. Corresponding angles. And since we know that the lines are parallel, then our theorem says that when we have two parallel lines being cut by a transversal, like we have in our diagram, then corresponding angles are going to be congruent to one another. So I can find out what this 5 parentheses 2x minus 1 is, it's going to equal, or it's going to be congruent to theta. So I would know what theta is then. Well, to do that, I'm taking a look at this 3 parentheses 8x plus 5. I notice that these two expressions are making up this line right here. These guys are a linear pair, which means they're going to add up to 180 degrees. They make up that line, and the lines are 180 degrees. So, like we did in number 1, we can do 3 parentheses 8x plus 5 plus my other angle and set it equal to 180. So plus 5 parentheses 2x minus 1 equals 180. I'm going to line down my equal sign. We have a couple of extra steps on this one. I'm going to go back and think about what our algebra steps are, where we need to distribute this number in front of the parentheses. So the 3 gets distributed to both of these guys inside of their parentheses. And the 5 does it as well with its parenthesis. So 3 times 8x. I'm looking at the first part here. 3 times 8x is 24x. Let me just quickly redraw that 4. It looks a little weird. So 24x plus, and now 3 times 5 is a 15. Plus, now I'm going to go over to the other parentheses, distribute the 5. So 5 times 2x is 10x. Plus 5 times negative 1 is going to be negative 5. So plus negative 5. Or we can just rewrite this as a plain old minus 5. Equals 180 on the right side. All right, so again, I've got some like terms that I'm going to want to combine. I have a 24x plus a 10x. I have a positive 15 minus a 5, or plus a negative 5. So 24x plus 10x is 34x. Plus a positive 15 minus 5, or plus negative 5, that gives me 10. Equals 180. All right, let's subtract this constant on both sides. X by itself, so 34x equals 170. And then lastly, I'm going to divide both sides by 34. Scroll down just a touch. So on the left side, the 34s will cancel, and we'll get just x. On the right side, when we do 170 divided by 34, we're going to get 5. So we'll get x equals 5. However, this is not our answer because we were not looking for what x equals. We want what theta equals. So what we got to do, since theta is corresponding with this 5 parentheses 2x minus 1, we're going to plug this 5 back in right here for x. So we'll do a 5 parentheses 2, and I'm plugging in this 5 in 5 parentheses 2, plugging in the 5 for x minus 1. All right, so let's get the stuff inside our parentheses first. So 2 times 5 is 10, minus 1 is 9. So 5, again, 2 times 5 is 10, minus 1 is 9. So 9 is left over inside our parentheses. And then 5 times 9 is 45. So that means that this angle highlighted in yellow is 45 degrees. And since it is corresponding in the same position as theta, theta is congruent. So our theta is also 45 degrees. All right. So number 3, we've got ourselves what I like to call a puzzle proof, meaning a proof with some blanks. It's partially filled in. We have to go ahead and fill in the rest. When we're doing proofs, we need to make sure that it makes sense, that it flows, and we're doing everything that's going to get to our end goal, the statement we are trying to prove. So our diagram is shown where K is parallel to L and M is a transversal. We're going to prove that angle 1 is congruent to angle 5. Angle 1 congruent to angle 5. One thing that we could note right away is that since our lines are parallel and M is the transversal, and we actually have this letter Z where 1 and 5 are alternate interior angles. However, that's not one of the reasons in the word bank. So we're going to have to try and show that those two equal each other. Not equal, but are congruent to one another without stating alternate interior angles. So line 1, they have filled in for us that K is parallel to L. That was given. That was pulled over here. Line number 2, I don't know the statement yet, but my reason is corresponding angles are congruent. So I need to look for a pair of angles that are corresponding, but also make sense. That's going to help us reach the end goal of 1 being congruent to 5, angle 1 congruent to angle 5. So I should probably look for a pair of corresponding angles that involve angle 1 or angle 5. So I'm going to look in the picture to see what angle is corresponding or in the same position as angle 1. That looks like angle 3. So I can look for angle 1 congruent to angle 3 because they're corresponding angles. And if I take a look at angle 5, the corresponding angle of 5 is this guy up here, which doesn't have a number. So that doesn't really make sense for anything there. So it looks like the only real option that's going to make sense in getting us to that end goal is 1 being congruent to 3. Angle 1 congruent to angle 3. Okay, so now, line number 3, we've got a blank statement and a blank reason. Again, our proof kind of needs to make sense and flow together. So if I have talked about angle 1 already, and my end goal has angle 1 being congruent to angle 5, my line 3 should probably mention something about angle 5. I got to bring angle 5 to the party. Otherwise, we're just going to have angle 5 at the end without ever explaining how it got there. So I should mention something about angle 5 for number 3. Well, taking a look at the options, I have a couple of statements that have angle 5 in them. Only one of them really makes sense with our proof, and that would be this guy right here, because we have already talked about angle 3, so we can now say angle 3 is congruent to angle 5. And we want to bring angle 5 to the party because that's part of our end goal. And angle 3 is the only other angle that we've talked about in this proof so far that is being stated as congruent to angle 5. So now we got to think about the reason why we can say that. Angle 3, angle 5, it looks like they are across each other on this x. Well, that would be a pair of vertical angles. So that looks like this guy right here. Vertical angles are congruent. So vert angles congruent. Let me redraw this angle symbol. So vertical angles are congruent. All right, so now I have connected angle 1 to angle 5. But I got to think about the reason why that is the case. So I said in line 2, angle 1 is congruent to 3, and then angle 3 is congruent to angle 5. So therefore, angle 1 is going to be congruent to 5. This is our transitive property. When we have 3 things that we are saying are equal or congruent to each other, that's the transitive property. I'm going from 1 to 3, then 3 to 5. That means I can go from 1 to 5. That's the transitive property. So this is this option down here. Again, 3 things being equal or congruent to each other is the transitive property. All right, and last one on this we do is we've got a multiple choice of a partially completed proof, but it's not in our 2-column proof that we're used to. It's kind of a couple sentences that they're explaining. So let's go through this. We got lines J and K here are intersecting to form these 4 angles, 1, 2, 3, and 4 as shown in the diagram. Elliot is trying to complete the proof that angle 3 is congruent to angle 1. angle 3 congruent to angle 1. Again, we might be able to right away say, oh, those guys are vertical angles. I know the congruent. But we're going to go through this proof that Elliot is doing without the assumption that that is true. We're going to try to figure out this without using vertical angles. So Elliot first notes that angle 1 and angle 2 form a linear pair. So I'm going to erase this and re-highlight this. So angle 1 and angle 2 are forming this linear pair. They make up line L. And then he says, as do angle 2 and angle 3. So angle 2 and angle 3 also form a linear pair. They form this line K. So we have two pairs of linear pairs here, 1 and 2, and then 2 and 3. He then notes that the measures of angle 1 and angle 2 have a sum of 180 degrees. We know that that is what a linear pair is. A linear pair adds up to 180. So that means angle 1 plus angle 2 equals 180 degrees. Because they are supplementary. That's what a linear pair is. Next, he notes that the measures of angle 2 and angle 3 are also going to be 180 degrees because they're also supplementary. They're their own linear pair. So we're going to figure out which statement should be next in Elliott's proof. Again, when we're thinking about proofs, although this is not a two-column proof, we need to think about, does it make sense? Does it help us reach the end goal? Does it flow together? So when we take a look at what we are trying to prove, so it says Elliott is trying to complete the proof that angle 3 is congruent to angle 1. So we've got angle 1, angle 2, linear pair. They're supplementary. Angle 2, angle 3 are also a linear pair. They're supplementary. We just got to connect the dots. So let's go through these answer choices, see which ones make sense, see which ones we can eliminate because they don't really make sense. So option A, we have angle 1 and 4 form a linear pair. So that is true. Angle 1 and angle 4, they do form a linear pair. But does that help us reach the end goal? Does bringing angle 4 into the party help us reach the end goal? Not really, because we already have talked about angle 1 and angle 3, and that angle 2 is somehow the connection point between them. So we don't really care about angle 4. We already have the pieces. We just got to make sure we pick the correct next statement. So although option A is a correct statement, it doesn't help us get to that end goal. Option B, angles 1 and 2 each have a measure of 90 degrees. Well, it doesn't look like it is ever stated that that is true, nor do I see any symbol that shows that we have right angles here. So I can't assume. It could be 80 degrees, it could be 70 degrees. Nowhere does it say it's 90 degrees. So that is definitely not going to be our next statement. Option C, the measure of angle 1 and the measure of angle 3 have a sum of 180 degrees by substitution. So substitution. If I can do measure of angle 1 plus the measure of angle 3 somehow equals 180, then that would be true. That would be our substitution. But nowhere am I seeing that I can sub in the measure of angle 1 into this statement. So I don't think that that is really going to help us here. Plus, we're already thinking about how 1 and 3 have to be congruent to one another because they're vertical angles. So it doesn't make sense that they would have a sum of 180 degrees because we don't necessarily know that they're going to be 90 degrees. Nowhere does it say 90 degrees. So C doesn't really make sense. So that leaves us with choice D. But let's go through it just to know why that's the case. So the sum of the measures of angles 1 and 2 is equal to the sum of measures of angle 2 and 3 by substitution. So here what they're saying is since both of these statements equal 180, since they both equal 180, they can be subbed in for one another. So I can take this statement right here, since it equals 180, and replace it right up here. So I can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. Because they both equal 180, they can be subbed in to equal one another. That makes sense to me. So that does mean that D is going to be our correct next statement.